transfer the amount, to deposit the amount. That is the second transaction we are doing. Next, after inserting or after doing any operation, the third step of transaction is transferring the money. So here, a transaction before a database before transaction and a database after transaction should be in consistent state, even if we are doing any transaction. That is our main concept, main thing. If we are doing any modifications in a database, before transaction is consistent and after a modification of database is inconsistent, means that may leads to data inaccurate, or data, it will not maintain data integrity. So some of the problems or some of the issues may occur during some transactions. So we have seen some examples. So how to transfer a money or things from one account to the other account. Suppose I want to transfer 300 100 rupees from account A to account B. So what I will do first, I will going to read whatever the thing is there in A. So already in A's account 300 is available. So reading 300 will be the first step or first operation. After that, my intention is to transfer 100 rupees from account A to B. So A equal to 100, A minus 100. Now what will happen after that? Second step, 100 will be detected, right? In third step, what will happen? Now account A is having 200. Why? Because it is detected and we can read that 100 in B. So reading B. B will become now 500. Okay. So B equal to B plus 50. Not 50 here, 100. So after reading B, it will happen, or it will give a calculation of 500. So what is my intention? The database before transaction, after transaction, it must be same. That is called consistent state. If at all before transaction is different and after transaction is different, means this may occur or this may leads to inconsistent state. So for that reasons, we'll use some properties like transaction properties called as acid properties, atomicity. So in atomicity, like it is used to get the integrity of data, and it is also going to maintain accuracy, completeness of data. So here the transaction must be atomic, nothing but a single value. Okay, so here atomicity in operations will perform either all operations of transactions will be performed, or none operations are done. So if one side of transaction is failed, means entire transaction it is going to fail. So two operations will be performed in atomicity, that is abort and commit. So abort is nothing but the changes made to database are not visible. The meaning of abort is the changes made to database are not visible. Next, coming to the commit. Commit is nothing but changes made to database are visible. That is the main difference between abort and commit. So here also we have seen one example for atomicity. Next, coming to consistency is nothing but correctness. A transaction when started to execute, okay, must consider consistency, nothing but correctness of a data. So during transaction execution, the data may be temporarily will be in inconsistent state, but after doing the transaction, it will become a completeness or correctness. So the transaction completed successfully, the base will be in consistent state. Next, coming to durability is nothing but whatever that we are doing the transaction, the data should be in correct mode or accurate way. Okay, once the user has been notified the transaction has been completed, the updates it will be given to the person or a customer. so that the transaction will be permanent. Like if we are doing any transactions in PhonePe or GPay, what will happen? The history it is going to maintain, right? Whatever we have done the transactions to the other persons, other customers of PhonePe, that whole history will be maintained without loss of data. That is what durability. Even if any software or hardware failures is there, the data will not be lost. Next, isolation. Isolation is nothing but it will be ensured that it will showing that running transaction sequentially. That is one after the other. Okay. So here in between step 3 and step 6, what is step 3 here? Write A. What is step 6? Write B. Another transaction T2 is allowed to access the partially updated database. So it will see in and consistent database when we are doing any transactions, like sum of a plus b is less than, it should be less than a plus b, t1 and t2 while reading a and b. So such type of things are executing multiple transactions concurrently has significant benefits. So simple transaction model also I have explained yesterday, that are two operations, read and write. So read meaning is nothing but reading the database from where to where, database to local buffer. Whereas write from local buffer to the database. Next, storage structure. As we know, the main intention is DBMS is nothing but database management system. So where we can perform some operations like modifications, insertion, deletions, and moreover, after doing all these operations, we have to store the data. So storage structure. Coming to storage structure after doing the transaction, to understand how to ensure the atomicity and durability, we know already what is meant by atomicity. The data should be consistent even if transaction has been done. Okay. So what is meant by durability? So durability is nothing but it is going to maintain history of data, even a system or hardware failure occurred. So here to ensure the atomicity and durability of a transaction, we must understand how various data items of database may be stored and accessed. So depends on the speed, performance, capacity, resilience. Okay, failures of storage media, and these are classified into the following, like volatile storage, non-volatile storage, stable storage. Okay, so let us see what is meant by volatile storage. Volatile storage is nothing but the information does not survive even the system crashes, means the information will be lost. Volatile storage, main memory, cache memory. So it is extremely fast due to the speed of memory access, and it is impossible to access any data item directly. Why it is volatile? Because it will not access the data directly. Because if at all the data, we want to retrieve any data, first the user will be having the user will be storing the data in some hard disk or in a storage in clouds, like that. Okay, so here it is extremely fast due to speed of memory access. It is possible to access any data item directly, and here example is main memory and cache memory. So main memory will not hold large amounts of data. So whenever any system failure occurs, means information does not survive for longer time. Okay, it will be there, but it will not survive for longer time, years of years. Next, coming to non-volatile storage. Non-volatile storage is nothing but information will be survive even system crashes occurs or any system failure occurred. So here called as secondary storage, like pen drives, magnetic disk, tapes, flash drives, mm, hard disk storage, like that. Okay, non-volatile is a permanent one. Volatile is a temporary thing. Okay, example for volatile is a main memory, cache memory. Coming to this one, information will going to survive even a system is failed or even a hardware is failed. So example is secondary storage device like magnetic disk, tapes, flash storages, etc. So it is slower than the volatile storage due to random access. There we are having the fast, extremely fast. Due to the speed of memory access, it is possible to access any data. Very fast it will be there. It is slower than the volatile storage due to random access. So some of the suspectable failures may lose the information. It is rarely will happen in non-volatile storage. Next, stable storage. Information never lost here. Stable storage. To implement this information, it is replicated in servers. Servers will maintain the database so that it will not lost forever. Okay. They'll maintain number of servers, not only a single server. If you take the India only, India, some of the cities or some of the countries you take, they'll maintain the servers database at different locations, multiple location. That is what consistent data isolation. Okay, so even if at all any one failure of one server failure of server occur means what will happen, the data we can get from the another server. Okay, stable storage, information never lost from the stable storage. To implement this, information will be replicated, nothing but duplicated in servers. So this is a non-volatile storage media. So updates will be done with a care. Or whatever the updates we are doing, it should be done with a care. Next, transaction state. So there are some stages of transaction. A transaction when executing, it must have or it must follow some conditions or some states. That is what first one is active state. So this is the initial state. The transaction stays in this state while executing. Okay. So active state is the initial state. So that what will happen here? The transaction stays, the transaction whatever we are doing, that will be staying in this state. Okay, while executing, where it will stay in active state only. Next, coming to partially committed. Partially committed is nothing but after the discovery of the normal execution, it can no longer proceed. Okay, after discovery of the normal execution, it will not be there. Okay, that is what failed. Partially committed after final statement has been executed. Partial committed is nothing but after final statement, whatever transaction done, will get final statement, right? That has been executed. That has been executed. That is partially committed. Next, aborted. We already we have seen this aborted and committed in atomicity, two operations, right? So aborted is nothing but the database will not be visible. Okay, here the transaction may not complete its execution successfully. Okay, after the transaction has been rolled back, again repeated, the database will be stored its state prior to the start of the transaction. Two options after this it has been aborted. We can do two options. We can perform two options after aborted. Restart the transaction or kill the transaction. Restart the transaction or kill the transaction we can do in aborted operation. Okay. Next, committed. Committed is nothing but after successful completion, the transaction will be completed. So this is a state. So let me explain one more time. So active state is the initial state. The transaction stays in this state while executing. While doing any transaction, the execution thing, this is an initial stage where the transaction will be stay. Next, partially committed. Committed means successfully done, right? Partially committed. After final statements, this will be executed. Next, failed. What is the meaning of failed? After the discovery that normal execution were no longer proceed. Next. So aborted transaction may not always complete is executed successfully. After transaction, it should be rolled back. Why? To again go to the active state. So that if at all the transaction is aborted, two options are there. That is one to restart the transaction so that it can be done only if internal logical error is there. We can restart the transaction. Otherwise, second one is kill the transaction. Next, committed. Committed is nothing but it is the end of the statement after successfully done the transaction. So this is a state diagram of transaction. First state is active state where the transaction it is going to start its execution. If at all it is partially committed means it is going to do the full transaction. Otherwise, if at all any system failure occurs means it will be going to failed state. Then the transaction it is going to aborted. See the arrows. Next. Hmm. So implementation of atomicity and durability. As we know that what is meant by atomicity, what is meant by durability. So recovery management components of database system, it is going to support atomicity and durability. Okay. So atomicity can be implemented by shadow copy scheme. Atomicity can be implemented by shadows copy scheme. It makes a copy of database. Okay, which one? Atomicity. That is called as shadow copies. It assumes the database is simply a file on disk. A pointer is called as database pointer. It is maintained on disk. Its point, okay, the current point which are it points to the current copy of the database. A pointer called as database pointer. It is maintained on disk. It points to the current copy of database. So in shadow copy scheme, a transaction that wants to update the database first and creates a complete copy of the database. So what is meant by shadow copy? It makes a database, which one atomicity called as shadow copies. Now it assumes the database in a simple file on disk. Okay. After doing this one, a pointer called DB pointer, it is maintained on the disk. It is pointing towards the current copy of the database. We already know what is meant by shadow copy. Shadow copy means it makes the copy of databases. Okay. So here a pointer called DB pointer is maintained on disk. It points to the current copy. What is the current copy of the database? In the shadow copy scheme, a transaction that wants to update the database first creates a complete copy of the data. So what will happen in shadow scheme? A transaction that will update the database first, it is going to create a complete copy of that database. All updates are done on the new database copy, leaving the original copy is untouched. Original copy will be neglected. Okay. So this is the implementation of atomicity and durability. So coming to the transaction, if the transaction is aborted, it is going to delete the new copy and the old copy of the database has been affected. So it is going to delete the both the new copy and old copy. Next, successful means it is committed. A new copy of database is written out to the disk. DB pointer moves to the new copy and old copy will be deleted. So before update, what is the thing happened here? Old copy of database is there in by the DB pointer. After update, old copy of database will be deleted, new copy of the database will be maintained. Next, transaction isolation. Up to this clear or having any doubts? డౌట్స్ ఉంటే అడగండి అమ్మా చెప్తాను. ఇది మొత్తం థియరీ ఉంటుంది కంప్లీట్ గా, క్వెరీస్ ఏమి ఉండవు, కాన్సెప్ట్స్. చెప్పండి అమ్మా, డౌట్స్ ఉంటే ఏమన్నా అడగండి. ఐఎమ్ గివింగ్ 1 minute ఆఫ్ టైం. సార్ చెప్పండి, ట్రాన్సాక్షన్ స్టేట్స్ లో యాసిడ్ ప్రాపర్టీస్ లో ఏమైనా డౌట్స్ ఉంటాడు. అర్థమైందా? అట్లీస్ట్ చాట్ బాక్స్ లో మెసేజ్ పెట్టండి, సేస్ ఆర్ నో. ఉన్నారా అమ్మా? నిద్రపోతున్నారా? ఆన్ చేసుకొని. గాయస్ ప్లీజ్ బీ ఇంటరాక్టివ్ మా. Next, transaction isolation. So multiple transactions are allowed to run concurrently in the system. Transactions. So a same person can transfer some amount to the same person. Okay. So like I am is there, some other person is there. We both can transfer amount to the other person. Okay. Simultaneously. Multiple transactions are allowed to run concurrently in the system. So what is the advantage with this means? It is going to increase the throughput and resource utilization. That means one transaction can be used by the CPU while other can be read from the disk. Like if and take myself only example. Now I'm sharing my screen with my laptop and I'm speaking through my phone, my device. Okay. Okay. So two things will be happening at a time, right? So two works are doing simultaneously, performing simultaneously. Okay. One transaction can be used by the CPU while other transaction can be read from the or writing from the disk. So reduced response time for the transactions or short transaction need not to wait behind long ones. Okay. Concurrency may leads to the database and this will enter into the inconsistency. So whenever the transaction problems in isolation occurred means concurrency will be leads to inconsistency state. So correctness will not be maintained for each and every individual of a transaction. To prevent this one, we use a mechanism called as concurrency control schemes. That is our next topic. Okay. Whenever we are doing any transaction isolation implementations, we'll get some errors. So that may leads to inconsistency state. So to avoid or to prevent these things, a variety of mechanisms called as concurrency control schemes are used. Okay. Next, schedule. We already know what is meant by schedule word, right? Schedule is nothing but a sequence of instructions maintaining in an order, chronological order. Okay. instructions are maintained in a chronological order. Schedule, time, okay. When we are going to do the transaction, what is the time? Okay, a schedule is a sequence of instructions that specifies the chronological order in which instructions of concurrent transactions are executed. A schedule for a set of transactions must consist of all instructions of these transactions. So what is the meaning of this one means? A schedule which is there for a set of transactions, it must be consists of all instructions to the all transactions. So this is going to preserve the order in which the instructions appear in each individual transaction. So a transaction is successfully completed. Okay, when it is going to complete successfully, when it is going to committed. So after doing all the transactions, it will leads to partial and partial will be leads to committed state. So after happening all these operations, it will have the last instruction is commit. So that it will taking as last statement. By default, transaction assumed to execute the commit instruction as it is a last step. So a transaction that fails to successfully complete its execution with an abort instructions as the last statement. This is what schedule. Schedule is nothing but a sequence of instructions that specifies the chronological order in which the instructions of concurrent transactions are executed. Mm. So let us see schedule 1. What is meant by schedule 1? So here let T1 transfer some amount 50 from A to B, rupees of 50 from A to B, and T2 transfer 10% of balance from A to B. Okay. So what is our first one? T1 will going to transfer rupees 50 from A to B, and T2 going to transfer 10% of balance from A to B. So two things will be happen. In T1, 50 will be transferred from A to B. T2 is going to transfer 10% of balance from A to B. So for this example, see the schedule in which the T1 is followed by T2. First, what is it is going to do, like we have done in atomicity, all those things, it is going to perform the operation. Like first it is going to read A. Then what is our intention? It should transfer 50 to B, right? From A account to B account. So here A equal to A minus 50. Next, write A. So what will happen? Write A. So A will be deducted 50 rupees. Next, read B. What is read B here? Read B will become now plus 50. B plus 50. Okay, write B. Write B means here the total amount will be added and the last step is commit. Okay, next T2. What is T2? T2 should transfer 10% of balance, right? So read A. First it is going to read A. How much amount is that? Next, temp equal to A into 0.1. Why? Because we need to transfer 10% of balance from A to B. So temp equal to A into 0.1. Next, what will happen? A equal to A minus temp. A equal to A minus temp. Now, a fourth step is write A. Write A so that it is increased or it is going to transfer 10% of balance from A to B. Next, read B and B plus temp. So B will be added 10% of balance from A to B. Here minus, here plus. So this is what schedule 1. So let T1 transfer rupees 50 from A to B. T2 transfer 10% of balance from A to B. An example for serial schedule is T1 is followed by T2. Here first step read A equal to minus 50. Next write A, B equal to B plus 50. Write B, commit. Next read A, temp equal to A into 0.1. Next A equal to A minus temp. After that, it will going to read A. Next, read B. Write A, read B. B equal to B plus temp. Write B and commit. So in this way, schedule 1 will be happen. Up to this clear? Say yes or no? Next, schedule 2. A serial schedule in which T2 is followed by T1. So first, T2 function is to transfer account, right? Transfer 10% of balance from A to B, right? So first T2 will be performed. That is nothing but first transactions will be performed by T2. So that is what T2 comes first. Read A temp equal to A into 0.1, A equal to A minus temp, write TA. Next read B, B equal to B plus temp, write B, commit. Same, whatever the things happen, first T2 will be happened. Next T1. Read A equal to A minus 50. Next write A, read B, B equal to B plus 50, write B, commit. Next schedule 3. So here let T1 and T2 transactions defined previously. The following schedule is not a serial schedule, but it is an equivalent to schedule 1. So T1, T2, two transactions, read A equal to A minus 50, reading A. After reading A, what will happen? Here transferring A temp equal to A into 0.1. So A equal to A minus temp, write A. Next read B, B plus 50, write B, commit. Next read B, B equal to B plus temp, write B, commit. So here 1, 2, 3 is a like schedule are same, but sum of A plus B is preserved. Next schedule 4. Concurrent schedule does not preserve the sum of A plus B. So here read A, okay, read A equal to A minus 15. Next read A in T2 transaction temp equal to A into 0.1. A equal to A minus temp. Write A, read B. Next T1, write A, read B, B equal to B plus 50, write B, commit. After that, we need to transfer, right? B equal to B plus temp, write B, commit. So this is what schedule 4. Next, serializability. Before going to serializability, up to this clear, share what is meant by schedule and what are the schedule 1, 2, 3, 4. Yes or no? అర్థమవుతుందమ్మా చెప్పండి. Just doing a transactions. No. Which topic I have to explain? ఎస్ మా నో అన్నారు కదా, చెప్పండి ఒకసారి ఇక్కడ ఏది చెప్పాలో. చెప్పండి అమ్మా, ఏది చెప్పాలో చెప్తాను, మళ్ళీ రిపీట్ చేస్తాను. షెడ్యూల్ నుంచి చెప్పాలా? నో డౌట్సా? నో మ్యామ్ అంటే నో డౌట్స్ మ్యామ్ అంట. ఏందమ్మా మీరు? ఓకే, సో లెట్ మీ గో టు నెక్స్ట్ టాపిక్, సీరియలైజబిలిటీ. మా ఇవన్నీ ఈజీగానే ఉంటే ఒక్కసారి మీరు చదివితే గుర్తుంటాయమ్మా. The serializability is a process to use to find out or find a given non-serial schedule. Okay, serializability is a process used to find two things, non-serial schedule and serial schedule. So here, non-serial schedule is a serializable schedule. Serializable schedule, it is going to provide a consistent result. Okay. So serializable, two things are there in serializability. Serializable schedule and non-serializable schedule. So serializable schedule provides consistent result, a constant result. Non-serializable schedule, it will not give a consistent result. It will give inconsistent result. Next, it results equal to the results of its transaction executed serially. Okay, based on this, it is going to give a transactions executed serially and one by one. So here it results not equal to the results of transactions executed serially. So coming to non-serial schedule, what will happen in non-serial schedule? A non-serial schedule should be executed, that is serializability is used to find given schedule is serializable or not. Okay, here two things will be there, that is conflict serializability, view serializability. Conflict serializability and view serializability. So let us see what is meant by first one, conflict serializability. So conflict serializability is used to check whether a given non-serial schedule is conflict serializable or not. What it is going to do? It is going to check whether a given non-serial schedule is conflict serializable or not. Next, it is going to perform the process by converting a given non-serial schedule into a serial schedule by swapping its non-conflicting operations. Okay. So let L1 and L2 are two instructions here. T1 and T2 are two transactions here. So instructions L1, Li and Lj is a conflict if and only if there exists some item Q accessed by both Li and Lj. At least one of these instructions wrote Q. So if two transactions are performing the operations on the different data items, then those are called as non-conflict operations. What is meant by non-conflict operations? If two transactions are performing operations on different data items, that are called as non-conflict. If two transactions are performing the operations in same data items, we call it as conflict. Okay. So operations on same data items called as conflict operations. So there are some cases, test cases. See here, let Li and Lj are two instructions of transactions Ti and Tj respectively. Instructions Li and Lj are conflicts. Okay. So here, if and only if there exists some item Q that is accessed by both Li and Lj, and at least one of these instructions wrote Q. Let us see the first one, T1. Here, Li equal to read, Lj equal to read Q. What will happen here? Two transactions, right? Not transactions, instructions. So here Li and Lj don't conflict or will not conflict. Will not conflict means what will happen if two transactions are not performing on the different items. Here it is performing on the different items, right? So that it is called as a non-conflict. So here read write is there. They will conflict, right? In different platforms. If any of the right operation is performed means you need to remember that will be conflict. If you observe here in step 2 right is there, step 3 right is there, step 4 right is there. So they are called as conflict. Okay. So here both read or means it will not conflict. Same data items will not conflict. Different data items which are there that will go into conflict. Okay. So intuitively A conflict between Li and Lj forces a temporal order between them. Li and Lj are consecutive schedule and they do not conflict. Their results would remain same even if they had been interchanged the schedule. Even they have been changed the schedule, these are going to remain same. It will not get conflict. Next, conflict serializability. So here if a schedule S can be transformed into schedule S by a series, swaps the non-conflicting instruction, we say that S and S dash are conflict. Here S is the schedule and that will be transformed into S dash. By series of a swapping of non-conflicting instructions, we say that S and S dash are conflict equivalent. We say that S is a conflict serializable if it is conflict equivalent to a serial schedule. Next, a schedule 3 can be transformed into schedule 6. Why? A serial schedule will going to follow T2 follows T1 by series of swaps of non-conflict. Therefore, schedule 3 is a conflict serial. Here, if you observe T1, T2 are two transactions, read A, write A. Next in T2, same, read A, write A. Next after that, in T1, read B, write B, and T2, read B, write B. Okay. Next, here, what will happen? Read A, write A, all A operations will be done at a time. Read A, write A, read B, write B. Next, here, read A, write A, read B, write B. So this is the schedule 3 and schedule 6. Next, example. Example of a schedule that is not conflict serializable. Read Q, write Q, write Q. Here it is going to commit. We are unable to swap the instructions of the above schedule to obtain either serial schedule T3, T4 on the serial schedule T4, T3. So precedence graph. Precedence graph. Here consider some schedules and some set of transactions T1, T2, T3 up to Tn, n transactions. Precedence graph is nothing but a direct graph where the vertices are the transaction called as names. We draw an arc from T1 or sorry, we draw an arc from Ti and Tj, two transactions conflict, and this will be access data item on the conflict arose earlier. What is the meaning of this one? Means we draw an arc from Ti to Tj, two transactions like conflict. Next, which is there that is going to access, like Ti is going to access the data item on which the conflict arose earlier. We may label the arc by item was accessed. This is the precedence graph example. So what is happening here? A directed graph, it will maintain some vertices of transaction names. So it will going to draw an arc, just an arc from Ti to Tj, two transactions which is going to complete, where Ti will be access the data item from the which is conflicting. Next. Uh, Next one. See here. Testing for conflict serializability. A schedule is a conflict serializable if and only if its precedence graph is cyclic. Okay. So when it is going to say conflict serializable if and only if precedent graph is acyclic. A cycle detection algorithm will exist in which order n square time where n is the number of vertices in the graph. So better algorithms will take order n plus e where e is the number of edges, vertices and edges here. So here there are some vertices and some edges in the precedence graph that should be acyclic. That is called as serializability, conflict serializability, so that it can be ordered as a topology of sorting of the graph. So there is that is a linear order consistent state with the partial order of a graph. For example, a serial order for the schedule A would be a either B or C. If you observe here diagrams, Ty is there, Tj is there, Tm is there, T. So this is a precedence graph, acyclic graph. Next, coming to this one, it is also going to maintain edges and vertices. We can also write like this: T1, Ti, Tj, Tk, Tm. And also with reverse, we can write Ti, Tk, Tj, Tm. Next, మా అర్థమవుతుందా? అంత థియరీ అమ్మా. ట్రాన్సాక్షన్స్ ఎలా చేయాలి, T1 T2 ప్రెసిడెన్స్ గ్రాఫ్ అంటే ఏంటి, ఇవన్నీ. ఓకే, అర్థమవుతుందా? ఎస్ ఆర్ నో? So view serializability. It is a schedule S and S dash are said to be a view equivalent. It is going to follow the three conditions. First one is for each data item Q, if the transaction Ti, it is going to read the initial state or initial value of Q. Okay. What will happen in schedule S? Then the transaction Ti must be in schedule S. Also read the initial value of Q. Okay, for each data item Q, if the transaction Ti executes read Q in schedule S and the value of proceed produced by the write Q. So for each data item Q, if the transaction Ti is there, that is going to execute the read Q in schedule S. And if the value was produced by write Q operation executed by the transaction Tj, then the read queue operation of transaction Ti must in schedule S also read the value of Q that was produced by the same write queue operations of transaction Tj. So for each data item Q, the transaction that performs the final write queue operation schedule S must perform the final write queue operation in schedule S. So it should follow the three conditions for each data item Q. The transaction Ti should read the initial value. Then, after reading the initial value, the transaction Ti must have the schedule S dash. Or okay, so that it will be in initial value of Q. Next, after reading the data item Q, the transaction Ti should read in schedule S, so that it produce the value by write Q. After that, the operation should be executed between the Tj, and then it is going to read Q operations of transaction Ti. Also, the value of Q was produced by same write Q operations of transaction Tj. So after this one, transaction that should perform the final write operation in schedule S must be perform the final write queue operation in schedule S. So this is about view serializability. So two schedules are there, S1 and S2. That can be view equivalent if they satisfy the following conditions. Initially, it is going to read an initial read of both schedules must be the same. Suppose two schedules S1 and S2 are there. In schedule S1, if the transaction T1 is reading the data item A, and then S2 transaction, it is going also read A. ఏదైతే T1 లో అవుతుందో సేమ్ అది కూడా దీంట్లో కూడా అవ్వాలి, S2లో కూడా అవ్వాలి, షెడ్యూల్ 2లో కూడా అవ్వాలి. సో హియర్ T1లో రీడ్ అయింది, T2లో రైట్ అయింది. ఇక్కడ ఫస్ట్ రైట్ అవుతుంది, తర్వాత రీడ్ అవుతుంది, ఇనిషియల్ రీడ్. నెక్స్ట్ అప్డేటెడ్ రీడ్లో ఏమవుతుంది? ఇన్ షెడ్యూల్ S1 if Ti is reading A which is updated by Tj, then S2 also Ti should read which is updated by Tj. నాన్ సీరియల్లో S1 ఉంది, T1 T2 ఉన్నాయి, రీడ్ అవుతుంది, నెక్స్ట్ రైట్ అవుతుంది, దానిలో నెక్స్ట్ T2లో రీడ్ రైట్, దెన్ రీడ్ వై రైట్ వై, రీడ్ వై రైట్ వై. కానీ సీరియల్లో అట్ ఎ టైం అయిపోతాయి, రీడ్ ఎక్స్ రైట్ ఎక్స్, రీడ్ వై రైట్ వై, నెక్స్ట్ T2 ట్రాన్సాక్షన్లో రీడ్ ఎక్స్ రైట్ వై, రీడ్ వై రైట్ వై. సో S2 is a serial schedule of S1. It can prove that they are view equivalent, then we can say that a given schedule S1 is a view serializable. A final write must be the same between both the schedules. In schedule S1, transaction T1 will going to update at the last, then S2 final writes. Write A, next read A, write A. Next ఇక్కడ ఫస్ట్ రీడ్ ఏ అవుతుంది, తర్వాత రైట్ ఏ అవుతుంది, లాస్ట్లో T3 ట్రాన్సాక్షన్ అనేది కంటిన్యూ అవుతుంది. సో దిస్ ఈజ్ అబౌట్ ఫైనల్ రైట్. నెక్స్ట్ సో కంటిన్యూషన్ ఆఫ్ దిస్ వన్ ఎలా రాసారు? T3 T4 T6. సో T3 T4 T6లో ఫస్ట్ రీడ్ అవుతుంది, తర్వాత T4లో క్యూ రైట్ అవుతుంది, నెక్స్ట్ అగైన్ మళ్ళీ T3కి వస్తుంది, తర్వాత T6కి వెళ్తుంది. అదే S2 షెడ్యూల్లో T3 విల్ గోయింగ్ టు రీడ్ రైట్, నెక్స్ట్ T4లో రైట్ అవుతుంది, లాస్ట్ ఫైనల్ విల్ బి T6. So it is a view serializable in equal to view equivalent to the serial schedule T3 T4 T6, since the read queue instruction reads the initial value of queue in both schedules and T6 performs the final write of queue in both schedules. మా ఇప్పటి వరకు ఏమైనా డౌట్స్ ఉంటే అడగరా? Yes, what happened? Say yes or no. చెప్పండి అమ్మా. So every conflict serializable schedule is also a view serializable, but there are a view serializable schedules that are not conflict serializable. T3, T4, T6 ఉన్నాయి. Already we have seen this one. Read, the write, the write queue. So T4 and T6 are performing the write queue operations without having a performed read queue operation. T4, T6 ఏమవుతుంది? Only write without reading. Writes this type of things, T4 only, T6 performing write operations, right? So this is called as blind writes. Blind writes appears in any view serializable schedule that is not conflict serializable. So transaction isolation and atomicity. సో ఐసోలేషన్ లో రికవరీ అండ్ షెడ్యూల్ ఎలా ఉంటుందో చూద్దాం. సో ఇఫ్ a transaction tj reads a data from the previously written ti, then commits the operation అంటే successfully done the operation to the ti. It must appear before the commit operations of tj. The following schedule is not recoverable if t9 commits immediately after the read a operation. Read A, write A, read A, commit, read B. The T8 should abort and T9 should have to read. So this possibly shown a user. So this may leads to inconsistent state. So cascading rollbacks. Rollbacks are nothing but after the transaction is aborted, again it is going to roll back. Again it is going to repeat. A single transaction failure leads a series of transaction rollbacks. Consider the following things. Here in T10, T11, T12, read A, read B, write A. T11 లో ఏమవుతుంది? read A, write A. నెక్స్ట్ ఇయర్ T12 లో ఓన్లీ రీడ్ ఏ అవుతుంది. ఇక్కడ T10 లో ఆల్రెడీ అబార్ట్ అయిపోయింది. T10 లో ఫెయిల్ అయింది. T11 అండ్ T12 మస్ట్ బి రోల్ బ్యాక్. ఓకే, ఎందుకంటే T11 లో T12 లో అబార్ట్ అవ్వలేదు కాబట్టి. So by using the cascading rollbacks, it can lead to significant amount of work wastage of CPU time. So cascading schedule is also known as cascading rollback or cascading abort. Mm. So cascadeless schedules. So these are the each pair of transaction Ti and Tj, such that Tj reads a data item previously written by Tj and commit operations of Ti appears before the read operation of Tj. Every cascadeless schedule is also recoverable. It could recoverable అవుతుంది, and also it is desired to restrict the schedule to those that are cascadeless. An example of schedule that is not cascade. Here T10, T11, T12 ఇందాక చూసిన సేమ్ ఎగ్జాంపుల్. రీడ్ అవుతుంది, తర్వాత రీడ్ బి అవుతుంది, నెక్స్ట్ రైట్ ఏ, తర్వాత అబౌట్ అయిపోతుంది. T11 read A, write B, write A, and T12 also read A. Next, cascadeless schedule allows only committed read operations. Therefore, it avoids cascading rollbacks and saves CPU time. Okay. రోల్ బ్యాక్ అవుతుందంటే వేస్టేజ్ ఆఫ్ టైం. ఓకే, సో ఇట్ ఈస్ గోయింగ్ టు క్యాస్కేడ్ షెడ్యూల్లో క్యాస్కేడింగ్ రోల్ బ్యాక్ అనేది ఉండదు, అవాయిడ్ చేస్తుంది. ఓకే, సో T1, T2, T3 ఆర్ రీడ్ ఏ, రైట్ ఏ, కమిట్ అయిపోతుంది. ఇక్కడ కూడా T2లో రీడ్ ఏ, రైట్ ఏ, కమిట్, రీడ్ ఏ, రైట్ ఏ, కమిట్ ఇన్ T3. కమింగ్ టు దిస్ సైడ్, T1, T2, read A, write A, commit. T2, write A. So it is going to always allow committed read operations and uncommitted write operations. Transactions isolation levels. So here, serializable ensures usually integrated transaction isolations, but here repeatedly read committed will be using. Only committed records will be read, and repeated reads of same record must be returned same value. However, a transaction may not be serializable if it is going to find some records inserted by a transaction, not find others. So repeated గా రీడ్ దాన్ని ఓన్లీ కమిటెడ్ రికార్డ్స్ అని అంటారు. అండ్ again and again it will be going to read the repeated reads of same record must be same value it should maintain. So after a transaction it will not be serializable if it is find some records are not inserted in a transaction but not find others. So read committed, only committed records can be read, but successive reads of record may return different values. Even uncommitted records will be there in isolation levels, hidden things. So here dirty writes. ఇప్పుడు షాడో కాపీస్ స్కీమ్ చూసాము, ఇప్పుడు dirty writes. So all the isolation levels will going to disallow. It will not allow dirty writes. It is going to disallow dirty writes. What is meant by dirty writes? It disallows the rights of a data item that has already been written by another transaction. Okay, disallows the right of a data item already written by another transaction that has not yet committed or roll or aborted. డర్టీ రైట్స్ అనేది డిసలో చేస్తుంది. ఏంటంటే హియర్ ద డేటా ఐటమ్స్ విచ్ ఆర్ దేర్ దట్ ఆల్రెడీ రిటర్న్ బై సమ్ వన్ ఆర్ సమ్ ట్రాన్సాక్షన్ it will not accept. It will going to commit or abort. So SQL is possible to set the isolation level. So this is about serializability. ట్రాన్సాక్షన్స్ కాన్సెప్ట్స్ అన్ని కంప్లీట్ అయినమ్మా. ఇప్పుడు వరకు ఏమైనా డౌట్స్ ఉంటే అడగండి. ఇంకొకటి ఉంది B+3, అది కూడా ఎక్స్ప్లెయిన్ చేసేస్తాను. చెప్పండి అమ్మా, ఏమైనా డౌట్స్ ఉంటే అడగండి. ఇప్పుడు వరకు అర్థమైందా? ఎస్ ఓర్ నో? ప్లీజ్ అమ్మా చాట్ బాక్స్ లోనే మెసేజ్ పెట్టండి. అర్థమైందా, అర్థం అవ్వలేదా? మీరు ఏం మాట్లాడకపోతే నాకేం తెలుస్తుందమ్మా. నెక్స్ట్ B+trees. So B+trees are nothing but a balanced binary search tree. Already this you have learned in advanced data structures, but here it is also same concept in Dbms also. B+tree. B+tree is a balanced binary search tree. It follows a multi-level indexed format. Okay, what it is going to do? It is going to follow a multi-level indexed format. So in this B+tree, leaf nodes will be there, internal nodes will be there. So in leaf nodes will denote the actual data pointers. So B+tree ensures that all leaf nodes will maintain the same height. Okay. So one of the main important property that it will going to ensure that leaf nodes will remain same height. In the B+tree, leaf nodes are linked using the linked list. Therefore, a B+tree can support random access as well as the sequential access. So what is meant by B+tree? B+tree is nothing but it is a binary search tree. It is going to follow a multi-level index format. Then it will going to have the leaf nodes, and that is going to denote actual data pointers. Next, structure of B+tree. In the B+tree, every leaf node is at equal distance from the root node. The B+tree is of order n, where n is fixed for every B+tree. It contains an internal node and leaf node. For example, see the structure. D and G are there. So before D, we are having some leaf nodes that are A, B, C, D. C will be there up to C, and D is there. No, in between D and G, again we'll be having E and F also. So this is the structure. So every leaf of a node will be having the equal distance from the root node. Okay. So these are the root nodes, D and G are. So this tree is in order of n, where n is fixed for every B+tree. It contains an internal node and leaf node. Next, internal node. Internal node is nothing but an internal node of the B+tree contain at least n by 2 record pointers except the root node. except the root node. An internal node of the B plus tree contained at least n by 2 root record pointers. So at most an internal node will be there of trees contains an n pointers. So leaf node of the B plus tree contain at least n by 2. Uh, sorry. The leaf node B plus tree contains n by 2 record pointers and n by 2 key values will be there. So at least leaf node contain n record pointers and n key values. At most means maximum. Okay. So every leaf node of the B plus tree contains one block pointer P to point next leaf node. Next, searching a record in B plus tree. Suppose we are searching for a 55 in the below B plus tree. First, we'll fetch the intermediate node, which will directly to the leaf node that contain a record 55. So in the intermediate node, we'll find a branch of 50 and 75. Then at end, will be directed to the third leaf node. Here, Dbms will perform a sequential search to find 55. Here, 25 is there, 50 is there, 70 is there. In between 25 to 50, some 25 numbers are there, right? Next, we can take this before things like 5, 10, 15, 20, before 25. Next, after 25, 25, 30, 35, 40, and 50. Next, again 50, 50 is repeated here. 50, 55, 60, 70. After that 75, 80, 90, 50, 95. So here, if we are searching the node for a direct leaf node that can contain a record for 55. So here, what is the intermediate node here? We find intermediate node, we'll find the branch between 50 and 75. In between we need to get the fetch the details of 55, right? So where we can find in between 50 and 75, 50 to 75 మధ్యలో ఉంటుంది. So here then at the end we'll direct it to the third leaf node. Here dbms లో ఏం చేస్తుందంటే sequential గా search చేస్తుంది. Okay, so b plus tree insertion. Suppose we want to insert a record of 60 in the below structure, it will go to the third leaf node after 55. It is a balanced tree. Okay, insertion లో ఏమవుతుంది 60 రికార్డ్స్ ఉన్నాయి ఈ స్ట్రక్చర్ లో. సో ఇట్ విల్ గో టు ద థర్డ్ లీఫ్ నోడ్. ఓకే, థర్డ్ లీఫ్ నోడ్కి వెళ్తుంది. నెక్స్ట్ దాని తర్వాత ఇఫ్ ఎ బ్యాలెన్స్డ్ ట్రీ అండ్ ఎ లీఫ్ నోడ్ ఈజ్ ఆల్రెడీ ఫుల్, సో వీ cannot insert the 60 there. Okay, in this case we have to split the leaf node. Okay, leaf node అంటే ఇవి, internal root nodes అంటే ఇవి. Okay, in this case we need to split the leaf node so that it can be inserted into 3 without affecting the fill factor, balance and act. 25, 50, 75 ఉన్నాయి. బిఫోర్ 25 ఏమేమి ఉంటాయి 5, 10, 15, 20 ఉంటాయి. నెక్స్ట్ 50 మధ్యలో 25 to 50 మధ్యలో 25, 30, 35, 40. నెక్స్ట్ ఇన్ బిట్వీన్ 50 and 75, 50, 55. సో మధ్యలో ఉన్న నోడ్ ఏంటి 60. We need to find here 60, right? Inserting record is 60. So danni it will go to the third leaf node. Next, third leaf node has the value of 50, 55, 60, 65, 70. And the current root node is 50 lo undi. So this will going to split in a leaf node in the middle so that the balance will not be altered. So here we can group into 50, 55, 60, 65, 70 into 2 leaves. 2 leaves గా మనం తీసుకోవచ్చు దీన్ని థర్డ్ లీఫ్ ని. If these two has leaf nodes, the intermediate node cannot branch the 50. It should have 60 added. And then only a pointer can lead to the new leaf node. So this is how insert and entry will be happened in a normal scenario. Next, B plus tree deletion. Suppose we want to delete 60 from the above example. In this case, we have to remove 60 from the intermediate node as well as the fourth leaf node too. If we want to remove it from the intermediate node, then the tree will not satisfy the rule of B plus tree. So we need to modify and we have to maintain the balance tree. So after deleting 60, what will happen from the above tree? It is going to rearrange the nodes. It will show as follows. ఇక్కడ after deleting 60 node ఏమవుతుంది B plus tree and rearranging the nodes it will show as the follows 25 75. ఇప్పుడు మనం 60 ఇక్కడ డిలీట్ చేసేయచ్చు ఇందాక ఇన్సర్ట్ చేసినప్పుడు 5 వచ్చాయి లీఫ్ నోడ్ ఇక్కడ రాదు సో these are the things in B plus tree operations insertion deletion what is meant by B plus tree. So with this your unit 5 also completed. So up to this clear or having any doubts? చెప్పండి అమ్మా ఏమైనా డౌట్స్ ఉంటే అడగండి yes guys please be interactive you are having any doubts if at all you are having any doubts keep a comment in a chat box so that I'll explain once again. I'll send these PPTs, don't worry. I am going to share 4th 5th units. చెప్పండి అమ్మా ఏమైనా డౌట్స్ ఉంటే అడగండి చెప్తాను say yes or no you are having any doubts చెప్పండి అన్న ఏమైనా డౌట్స్ ఉంటే అడగండి చెప్తాను okay ma you all can leave all the best read all the units properly and first 4 units are very important you definitely you'll get in your exams all the topics and as well as in your gate exam also so thoroughly be prepared with the scripting language dbms all the best and thank you for your cooperation bye good night you all people can leave ma